let D is equal to A square plus B square plus C square, where A comma B are successive positive integers, and C is equal to AB, then prove that square root of D is an odd positive integer. So this is the question. Solution. So D is given as A square plus B square plus C square, and it is given that A and B are successive positive integers. That implies difference between A and B, that is mod AB, is equal to 1. Now square on both sides. So if you square on both sides, then what you get? A square plus B square minus 2AB is equal to 1. That implies A square plus B square is equal to 1 plus 2AB. Now put this A square plus B square in D is equal to A square plus B square plus C square. Then what you get? This implies, so D is equal to, so replace this A square plus B square in D with 1 plus 2AB. Then D will be 1 plus 2AB plus C square. And one more thing is, here C is equal to AB is given, therefore replace C with AB. So here replace this C with this AB. Therefore this is A square plus B square. This implies D is equal to, now this is 1 plus 2AB plus B square. So now this is a perfect square. So this is equal to 1 plus AB whole square. That implies square root of D is equal to 1 plus AB. So now A and B are successive positive integers. Therefore, if A and B are successive positive integers, then AB is an even number. So if AB is an even number, AB plus 1 is an odd number. Therefore, square root of D is an odd integer. Here it is given that A comma B are successive integers. Therefore, AB is even. Therefore, 1 plus AB will be odd. Therefore, square root of D is an odd positive integer. Therefore, square root of D is an odd positive integer. So this is the solution.